talk about complex numbers. This is going to be a part 1 out of 2 parts. Okay. Lots to talk about. I don't want you writing anything. Okay, we will write next screen. There's a lot for me to give you information on here. So let's simplify this one. Now just in the last screen when we did our review, I broke up that radical, right? Couldn't I also break up this radical? This could be 9 times -3, which is 3 times the square root of -3. Couldn't I also do this? Could I do that? Still the same, correct? All of these are equivalent. All right, let's take that and go over here. In fact, before I get here, let's talk about what we talked about, I think it was Monday, when I was asking you if you guys had ever seen what a square root looks like conceptually. For instance, remember this? So that's a 3 by 3 square, correct? What about this one? Good. Square root of 8 times the square root of 8 makes the area of 8, right? We talked about that? So wouldn't this make sense? The square root of -27 times the square root of -7 makes an area of -27? But what's wrong with this? But that's where we're getting at with the imaginary. What's wrong with this? Under the same... But the square, it doesn't go by the same rules, and that's why we're going to talk about it. But why? Why doesn't it go by the same rules? Because it's a why does this not make sense right here, guys? Because area can't be negative. Okay? Area can't be negative. If you said it, I didn't hear it. Okay? So if area can't be negative, that's why we call this imaginary. Now, this is as conceptual as I can get for you in an Algebra 2 class right now. Later on, I can show you some other examples, but we're going to get there a little bit more. Okay, so some of you said, but a negative times a negative is a positive, right? So under that thinking, it would be the square root of -27 times the square root of -27 equals -27 squared, which is just 27, but that's not what this says. This is why we need imaginary numbers. You follow? Because it doesn't make positive 27. It makes negative 27, which is imaginary. So instead of, in fact, I think, let's keep going on this first. Okay, so let's go back to this one. So when we have a negative underneath the square root sign, we have to call it something different because we're going to use different rules for it. So whenever you see a -1 under square root sign, that really means I. So this could be simplified to 3i root 3. Okay, now let's use that thinking and go back and look at this. If I had the square root of -1 times the square root of -1, let me get these out of here. My pen's not working very well today. I don't want to make this messy. All right, so the square root of -1 times the square root of -1 makes what? -1, the area of -1, right? But didn't I say that we call the square root of -1 I? So the square root of -1 is I. So couldn't I say I and I makes I squared? I squared is -1. Okay? Yes.
So the square root of -1 is I, and then Negative 1 is I.
The square root of negative 1 is I, and I squared is negative 1. Yes. The answer is the I. Yes, when you're manipulating I, it can be a negative number. It can come out to being negative. Yes. It's like you take it out if it's an I, you manipulate it a little bit because I has its own special rules. So it doesn't have negative rules, or the rules we usually use with negative numbers. I has its own special rules. But yes, you can get negative. Okay, so that being said, is everybody with me so far?
Yeah.
So whenever you see I, you should automatically visualize that really means negative under a square root sign. And when you see I squared, you should say I times I makes the space the area of negative 1. Okay? That being said, let's go over to this. What is anything to the power of 0? No. 1. I have 0 i's, so I just have 1. I don't have I, because this is really 1 times I. Right? So if I have 1 times I 0 times, I just have 1. What is I to the first power? What is I squared? Right? We already figured that out, right? I times I is I squared, which equals negative 1. This is really bothering me. My eraser won't work. Okay, negative 1. Let's look at I cubed. I squared times I makes I cubed, right? Well, we already figured out that I squared is negative 1. So I cubed is negative I. Okay, it's going to hurt a little bit. It's supposed to. It's exercising your brain. I to the 4th is I squared times I squared, which would be, let's move this over here. Negative 1 times negative 1 makes positive 1. But I to the 5th, isn't the I to the 5th I to the 4th times I to the 1st? Isn't I to the 4th 1 times I equals I? We'll get there. Yes, there's a pattern. There's a pattern. You should see the pattern coming. So we started with 1, I, negative 1, negative I. 1, I, what do you think this is going to be? Negative 1, next one will be negative I. Now, what does the pattern recycle at? Every what? Every 4th time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 12, 13, 14, 15, 16, right? It cycles in 4s. So all you really need is what's here in blue. And it goes the same way in the negative direction. So what would this one be? Negative I. And what would this one be? Negative 1. And what would this one be? Yes, you guys got it. Okay, so as long as you know this basic right here, you're good. Now let's use it. I to the 45. Crazy, right? I don't want to write all that out, so I'm not going to. So what should I do? Isn't I to the 45 I to the 44 times I to the 1? Isn't I to the 44 I to the 4th 11 times? Right? I to the 4th 11 times, right? Now you don't have to do this on your homework, but I just want to make a point. So I to the 4th 11 times is I to the 4th times I to the 4th times I to the 4th times I to the 4th. I have to visualize it, Jesus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one more I? Is that 45? Everybody agree? Isn't each one of these, okay, let's write down our pattern. I to the 0 is, I to the 1 is, I squared is -1, and I cubed is -I. So each one of these, what's I to the 4th then? It cycles right back up, right? I to the 4th cycles right back up to here. So isn't each one of these so isn't I to the 45 I? Yes. Yes, write this down. This is what you should be writing. All right, so let's look at this one. So I would say I'm going to change this into factors of 4. So what would I change 31 into? 30 and 1? That wouldn't help us. 29? No. Factors of 4, guys. You can't do 32. You could do 32 and go backwards if you wanted to. All right, that would be harder. So does everybody agree that 28 plus 3 makes 31? Is 28 a factor of 4? So this is actually I to the 4th how many times? 7, which means 7, 1, right? And what's I cubed? -I. If you can't remember that, you just quickly say I to the 0 is 1, I to the 1 is I squared is -1, I cubed is -I. Pretty easy, right? You always factored in 4s. So what would I to the 101 be? What is I to the 101? It would be I to the 100, which is a factor of 4, and I to the 1, which is I. Let's do another one. How about I to the 106?
We could do I to 100 or I to...
Which would be -1. Getting it?
-1 and then whatever you add the other one up. Oh.
Starting to see it?
So you just factor so you get one of those?
You've got to count in 4s. It's just like counting. Right? Isn't 100, guys, 106 is, you know that 100 splits into 4s, right? That's 25 times. That's 25 ones if you want to write them out. And then another I to the 4, which is another 1. And then an I to the 2, which is -1. This is 1 times 1 times -1. You just break it up. If that confuses you guys, you could also do this. 31 divided by 4. How many times does 4 go into 31? 7 times. What's left over? So there's my remainder. Matches.
That's a lot easier. That's way easier.
But that's not,
Concept.
yeah, you're not, that's like a rule.
That's like plugging and chugging.
But that's plugging and chugging is exactly what that is. But that's what you're doing when I do this, didn't I? I said 7 4s with 3 left over. It always does. Because I want you to see it, that's why. If you see it, you will make less mistakes. just like 104 you have to think of, or 106 you have to think of, that would be 26 fours. 25, 100 gets split into 4 25 times, right? Plus another 4 is 26, right? No, I don't want you to write it 25 times. That's because because I was showing you what it meant. I just want you to write this. In fact, if you just, let's erase this and give you another one. This is all I expect from you. What is I to the, give me one. 75. So what's the, 4 goes into 75 how many times?
18.
Let's do a smaller number so everybody can see it. 20? That's too much. How about 22? How many times does 4 go into 22? 5 times, right? Because 5 times 4 is, with how many left over?
2, so you put negative 1.
Negative 1.
Yes. Right?
Yeah, negative 1.
Yes. It is. It's the remainder. Isn't that the remainder?
So the answer goes to the remainder?
You see it now?
So it's just the fourth factor of the
Yes.
Always remainder.
It's always the remainder. So what about I to the 29?
That would be 12 and I 1.
28 with 1 left over, which is I. You got it? It's very abstract, but once you get the whole idea of it, it's not hard. Yes. I want to see it like this. I mean, it's not too hard to do, right? Exactly. Okay, you guys want another one?
Yes.
I to the I to the 9th. I to the 8th times
J. I mean, it's I. It's I. Positive. No, because you take off 1. You're just going by
Okay.
4.
Yes, we can do whiteboards again. All right, guys. What about this? Okay, but it's not that difficult. Just watch. I said it wasn't going to get harder, and it's not. Just check this out. I need to quiet. I'll wait. Isn't 3I times 4I also 3 times 4 times I times I?
Yeah.
Isn't that 12I squared?
Yeah.
Isn't I squared negative 1?
Yeah. Negative 12.
Do this one. Do you want me to start it? All right, let's break this one up. Isn't negative 20 underneath the square root also negative 1 times the square root of 20? Isn't the square root of negative 1 what? Keep going. Keep going. It's not all of it. Just keep going. Okay, so let's finish this one out. So this also could be rewritten like this. This is I. This is I. The square root of 20, isn't that 2 root 5 times I times 2 root 3? Correct? Rearrangement, isn't this I squared times 2 times 2 is 4 root 15? Why? It's not adding, it's all multiplying. You can't add them if they don't have the same basis. But you can multiply them because it's all multiplication. Because this is all multiplication. Good question. Okay, and what's I squared? Negative 1 times 4 root 15. So this answer is really negative 4 root 15. Evan?
Can it be like 4 root negative?
No. Because, okay, that's a good question, because if it was, we'll just do a little side note over here. This, right, that, like that, is really right? Is that the same as that? No. See the difference? Exactly. We good? You guys ready to do homework? Yes.
So you also do one thing was like you solve like what the radical 15 would be missing.
No, you don't need to do that for these. In fact, I'd rather you not. I'd rather you leave it just like this, because that's the way we're going to be manipulating them tomorrow. Okay, so what did you learn today? Eyes are imaginary, yes. What does an imaginary number look like conceptually? It's, guys,
It's a negative, right?
it's a negative area, right? An I times an I is a -1 inside of a box, inside of a square. The person next to you is asking, how would you explain the pattern of imaginary numbers? They're in groups of 4. Good. On your assignment sheet, what is I to the 0?
1.
What is I to the 1? What is I squared? What is I cubed? You guys got this.